All right, this is the Foundations of Mathematics and Pre-Calculus 10 sample questions for relations and functions solutions. So I will take you through these questions. Let's get started here with number one. So number one, as you'll see, is one where you cannot use a calculator for. So again, this would be one of the questions at the beginning of the test where no calculators are allowed. Number one, determine the x value of the point of intersection for the system represented by f of x is equal to 3 and g of x is equal to 5 over 2x plus 1. And so since we're looking for the x value of the point of intersection, we do know something kind of interesting here. If we start out with the f of x is equal to 3, this is the same thing as us actually saying that y is equal to 3. So we know that wherever these 2 points cross at, we know that the y-coordinate of the one graph is going to be 3. So this other function that we have over here, g of x, which is equal to 5 over 2 x plus 1, we can actually change that if we want to write it in terms of x and y. And this would be y is equal to 5 over 2 x plus 1. And so by substituting the information that we know over here into this equation, this can allow us to help figure out what x is going to be. So we substitute the 3 in for the y, and now we have 3 is equal to 5 over 2x plus 1. Gathering our like terms and bringing the 1 to the other side of the equation gives us 2. So subtracting 1 on both sides, it gives us 2 is equal to 5 over 2x, like so. And then by multiplying by the reciprocal here, we have 2, all multiplied by the reciprocal of 5 over 2, which is 2/5, is equal to x, which gives us 4 over 5. Or as you see what they have right here, they have them written in decimal format, meaning that the solution is 0.8. Okay, so there's the first one, done. Second question, again, no calculator. In which quadrant does the following system contain a solution? So what we'll do here is I'm going to paste in a graph. And when you're writing your exam, you'll be able to use graph paper. So we'll paste this guy in. And hopefully that'll help us graph this thing. Okay, so again, you'll have graph paper to graph this guy. So I'm going to, the first one I'll graph, and we'll put into y equals mx plus b. It already is in y equals mx plus b. The y-intercept is at 1, and the slope is 2. So I'm going to go up 2 over 1, up 2 over 1. And so I'm just sketching it out right now, so it doesn't have to be too terribly accurate. But that is about what we would get right there. Okay. Now, the other graph here, notice that it is in point slope form. Okay, so the point that we would get from this information right here is the point. Remember, you do the opposite value, so it's x minus 2. It actually means the x-coordinate is going to be 2. And the opposite of here would be a y-coordinate being 1, so it means the point is at 2, 1. So 2, 1 would be right here, and it has a slope of 1/2. So slope of 1/2 means we go up 1 over 2, up 1 over 2, or rise 1, run 2, like so. And now we'll go in this direction, like so, and we have our graphs like so. And so it asks, where is the point of intersection? And as we can see right here, the point of intersection would be this guy right in there. And if you forgot what the quadrants are, this is a problem that I've seen before. Students know clearly how to do this, but they don't know which quadrant 1, 2, 3, and 4 is. Quadrant 1 is always the one that we normally are working with, and then it works its way counterclockwise from this. So that would be 1, 2, 3 down here, and then 4, like so. Okay, so of course, where did this one happen in? It happened in quadrant 3, like so. So your solution is C. Okay, let's take a look at number 3. Determine the solution to the following linear system. Y is equal to negative 2x plus 5 is the first equation, and the second equation is 4x plus 2y minus 15 is equal to 0. So it's up to you how you want to do this. Of course, this is coming from Unit 7, Systems of Equations. You can solve this by graphing, elimination, substitution. I'm going to solve it by using substitution. Why am I going to do that? I'm going to do that because I see that the y is already isolated right here. So what I'm going to do is everywhere I see a y in the second equation right there, I'm going to substitute that information. So I will take 4x plus 2 all multiplied by my equation, which will be negative 2x plus 5, like so. And we will subtract 15, and that's equal to 0. So we have 4x plus, actually I'll end up making it minus 4x plus 10 minus 15 equals 0. And so what does that give us? The 4x's, notice how they cancel. We have 10 minus 15 is negative 5, and that leaves me with negative 5 is equal to 0. So negative 5 is equal to 0. Hopefully you are thinking that something fishy is up with that, all right? And so what that means, if you ever find one side of the equation is equal to a number and the other side of the equation is equal to a different number, that is always meaning that there's no solution, okay? So what this actually means, if you were to graph this, is that these points or these lines would never cross, okay? So there's no solution to this. In actuality, if we went and rearranged this thing should be parallel to it. And so as a result, the solution is C. Number 4, which of the following relations is not a function? And so remember, the definition of a function that we often use is that every input must have exactly one output. All right. So if we ever have an x, it's usually an x value, we normally call these our x values, as mapping onto more than one y value, then we have a problem. And lo and behold, we see that problem on letter A here. So it says which of the following is not a function. This one would not be a function because this 7 is mapping onto the 2 and 9. So that was a nice quick one. Solution is A. Number 5. The altitude of a plane is a function of the time since takeoff. Identify the dependent value. So whatever the function, so in this case, the altitude of a plane is a function of the time. We know that time, when you're graphing something like this, the altitude would be over here and time would be right here. It's because time is independent. It's always kind of going. And the altitude of the plane is therefore dependent on the time right here. So if you had a plane, the plane's graph might look, I don't know, something like this, and then maybe it's at altitude and then it comes down. So as a result, what is the dependent variable? The dependent variable in this case would be altitude, C. Number 6, determine the domain of the following relation. So again, the domain is asking for the x values. Basically, what x values are we allowed to have? I want to remind you what these two different dots mean. Remember that the closed dot means that you're going to include that point, and the open dot means you're going to exclude that point. So we have one of those. The brackets that we have down there, remember we use these square brackets for include, and we use the curly brackets, if you will, for exclude. So what we see here is the x coordinates. We're looking for what x values do we have? Well, this point right here looks to be at -4, and so we are going to include that. So that means we would have the square one on that side, and it goes all the way to what looks like to be 3 on this side, and because it is an open dot, we are going to have a curly one. And so that looks to me like it is B. Number 7, very similar to number 6, only of course now we're dealing with range. So range is asking for what y values are we allowed to have here. The maximum y value that we can have here would be at a height of 2, and the graph is going infinitely downward. So we can have anything from 2 and below. So 2 would be our maximum value. We are going to include that point, whereas negative infinity would be our minimum value. And when we do that, because you can never physically go and touch negative infinity, that's why we would end up using a curly bracket for that one. So your solution for this would be B. All right, number 8. A bag of caramel candies has a total mass of 180 grams, excluding the mass of the bag. Each candy has a mass of 6 grams. As a candy is taken out of the bag and eaten, the mass of the remaining candies is plotted versus how many candies are left in the bag. Determine the range for this relation. So to give you an example of what's happening here, right? We have 180 grams as our mass. And so we're going to keep taking 6 grams out until we get, of course, down to 0. So if you think, if we had 0 down here, grams, this would be 6, this would be 12, and so on. Up here, I guess we'd have 174, ... all the way to there. Now, what they're asking here is, well, what would the range look like? Well, if you look at A right here, it's saying that we would have 0, 1, 2, 3 grams in the bag. It's not possible because we know that the increments have to be in 6 gram increments. So it couldn't be that one. So we'll eliminate this. I'm going to skip B. C, if you take a look at it, it's saying that you could only have the masses in the bag of 0, 1, 2, 3, 4, 5, 6. That doesn't seem reasonable. D is saying that we can have all real numbers. That also doesn't seem reasonable because, of course, we're not going to be able to have 1, 2, 3, 4, 5 grams. We can only have multiples of 6. And so if you take a look, B, of course, is the ones that are multiples of 6. What does this little part right here mean? It means that it's going from 12 all the way to 180 by increments of 6. And so therefore, that's your solution. Number 8 would be B. Number 9, determine the equation of a line that passes through point A, which is located at 6, 0, and is perpendicular to the line formed by B and C, B being at negative 4, 9, and C being at negative 7, 10. So the thing I would key on right away is the word perpendicular. Of course, remember when something is perpendicular to it, it means that the slope is the negative reciprocal. So my game plan here is if I take these two coordinates right here and I find their slope, I know that the slope of this new line that we're trying to figure out is going to be perpendicular to whatever that is. So let's try and find the slope. So I'm going to write the slope of line, and I'll put the letters here, BC. Okay? So I'll go 10 minus 9. So remember, it's our y coordinates that we subtract. And then make sure you keep it in the same order. So if you took this one first and then that one, take that over here in the same way. So it'll be negative 7 minus a negative 4. Simplifying, we end up having 1 all over. Negative 7 minus negative 4 is the same thing as adding 4, which will give you negative 3. So that means that the slope of BC is negative 1/3. Well, what's the slope of the other one? So it says determine the equation of a line. So the slope of this other line, the slope of A and whatever, I guess, is going to be equal to the negative reciprocal of this, which would be 3. So right away I know I can eliminate C and D from the picture here. Now what I need to do is I just need to find out what the y-intercept is, looking like it's going to be either negative 18 or positive 18. So I know that my new equation is y is equal to 3x plus b. And the nice thing is they told us that it goes through this point at 0, 6. So I'm going to take this information and I'm going to substitute it in here. All right, so I will substitute the 6 goes in for my x coordinate, and the 0 goes in for my y, and of course we see that we end up getting 18 plus b is equal to 0, or b is equal to negative 18, being my y-intercept. Solution is A. 2 more questions, and these two I would say are the toughest by far. Number 10. A boat took 3 hours to travel 24 kilometers with the current. On the return trip, the boat took 5 hours to travel 24 kilometers against the current. Determine the speed of the boat. So one thing I think might help you a little bit is if we draw ourselves a bit of a chart. Okay. And so I'm going to put direction up here, and then I'm going to have distance, time, and speed. And likely in science you have already learned about an equation such as the following. Its speed is equal to distance over time. You might have remembered using a little triangle diagram to help you remember that. So anyways, the two different directions we have is we have one with the current and one I'll put maybe against. Okay, we'll put with current and against current. Okay, and the distance either way that we're going is still 24 kilometers. 24 kilometers for both those. Now, when we are with the current, it says that we are going to go 3 hours. So that's how much the time is. It's going to be 3 hours. And when we are against it, it is 5 hours on the return trip. Okay. Now, the speed. So the speed that we go here is going to be, we really don't know right now. So I'm going to make the speed x. Okay, it's going to be x and x. But here's the deal, is because we have the current going with us. So in the first row up here, I'm going to add whatever this current is. I'm going to call it C. I'm adding it. But if I have the other one going against it, of course I'm not going to add it. I'm going to subtract it, like so. And now what I'm going to go and do is manipulate this equation right here. I don't like dealing with fractions, so what I notice is that if I multiply both sides of the equation by time, I can say that speed times the time is equal to the distance. And I'm going to use that in these equations. So it's going to generate me two equations right here. It's just basically a Unit 7 systems of equations questions. I probably should have told you before that. So in the first case here, with the current, we don't know what the speed is, but we do know it's in terms of x plus c. So if you take x plus c and you multiply that by the time 3, we know that that's going to be equal to 24. And the other one is going to be almost the same. We're going to have x minus c, all times 5, is equal to 24. Okay. And so what I'm going to do is I'm going to distribute this 3 across the x and the c, so this gives me 3x plus 3c is equal to 24. And to make life a hair bit easier here, I notice that everything is divisible by 3. So if you wish, you can go and divide everything by 3. We now have x plus c is equal to 8. Okay, so I'm going to leave that there for now. I'm going to come to the other side and do basically the same thing. I now have 5x once I distribute this out here and here. 5x minus 5c is equal to 24. There's nothing I can reduce with that one, so I'm just going to leave it kicking right there. Now, whenever we had two equations, what we normally wanted to do is we wanted to try to either eliminate one of the variables or substitute or perhaps graph. Graphing is usually one of the least efficient ways. It's tough to find an accurate answer. So what I'm going to do here is I'm going to choose to solve this by, I think, substitution. I'm going to take one of these variables, I'll take the x, and we're going to rearrange it. So it's equal to, x is equal to negative c plus 8. So now everywhere I see that in this equation, everywhere I see an x, I'm going to substitute that in. So I have 5 all multiplied by negative c plus 8 minus 5c is equal to 24. All right. Now, I'm running out of real estate here at the bottom, but we'll try to make do. 5 times negative c is negative 5c plus 40 minus 5c is equal to 24. Gathering my like terms, I have a negative 5c and another negative 5c is negative 10c. Bring the 40 to the other side of the equation, that gives me negative 16. All right. Now, dividing both sides by 10, we end up getting c is equal to 16 over 10. The negatives cancel. And keep in mind that that's what we were looking for here. We were looking for what is the speed of the current, and the speed of the current is 16 over 10, which is the same thing as 1.6 kilometers per hour. Remember, if we were asking for what the speed is, then we would have had to go and figure out what x is, okay? So that's how we do that question. Kind of tough. What does it assume? It assumes you know a little bit of information about how to find the equation for speed, time, and distance, and it also assumes that you can make an equation out of that. So that's the tough part. I think the solving part is doable, but making the equation is the tricky part. All right, the last question in this sample package here. Number 11. Two acid solutions are to be mixed together. Solution A is 30% acid by volume. Solution B is 70% acid by volume. How much of solution A is needed to mix with solution B to make an 800 milliliter mixture that is 54% acid by volume? Answer to the nearest milliliter. Similar to the last question, another tough one in my opinion. It's also a systems of equations question. So the tough thing again is making the equations. Usually solving them isn't too shabby. So what I will do here is I'm first going to start off by trying to make a let statement. So I'm going to put the let statement up here. I'm going to let, let's say we'll use the variables x and y. I'm going to let x equal, let's do the number of liters of solution A, and the other one's going to be the number of liters of solution B. Okay, so always start out with your let statement. That will help the viewer. In this case, it's not that big a deal, but also help you understand what you're doing right here. And so now I'm going to develop two equations. The first equation, just to kind of label what we're doing, is going to be the equation for the percent of acid. And so what do we know here? Well, we know that 30% or 0.3 of solution A, which in this case we're calling x, plus 70% of solution B, which we're calling y in this case, has to give us a resultant that is 54% of our total amount. And the total amount that we have in this case is 800. So that is our first equation. The second equation that we're going to develop is that we need an equation for total volume. And the equation for total volume is this, that we don't know how much of solution A or solution B we're going to have, but we do know that when you add those together, it's going to have to make 800. So that one's the relatively easy one. It's just x plus y is equal to 800. All right. Now, at this stage, we have our two equations. The first thing I would suggest is that you might want to go and multiply this part out right here. And if you multiply this part out right here, I've multiplied this out previously, you end up getting 432. Okay, so I'm going to solve this, I believe, by substitution. So I'm going to take this equation here and I'll just rearrange it for x. X is equal to, I'll do 800 minus y, and I'm going to substitute that into the other equation. So I have 0.3 all multiplied by this information right here, 800 minus y plus 0.7 y is equal to, and remember we had changed that number to now be 432. So distributing this out, 0.3 times 800, well, 30% of 800 is 240. And then we'll multiply the 0.3 times the negative y, that gives you negative 0.3y. plus 0.7y is equal to 432. Gathering my y's right here, that gives me 0.4y, and subtracting the 240 onto both sides of the equation gives me 192. And then lastly here, to go and get rid of the decimal that we have here for next to the y, we divide by 0.4, divide by 0.4, and that gives me y is equal to 480. Okay, so remember, 480y, that's how much of solution B we had. The question said how much of solution A is needed. So that would be a common mistake that students might plug in an answer for this. They might answer 480. So your question might be, how do we figure out what x is? Well, to figure out what x is, right, we can just substitute into this equation up here, if you will. So we have x is equal to, I know it's kind of getting ugly here, but x is equal to 800 minus 480, and we end up getting x is equal to a solution of 320 milliliters. So remember, when you are plugging this one in, because this would be a written question, you'll notice that there were no multiple choice answers. You're going to have those weird little box guys. And so because the answer is exactly 480, there was no rounding, you would just put in 480 like so, no 0, 0. And of course, if you want to, you could have filled in the positive dot. Although if you didn't fill in the positive dot, it will assume that it is positive. Okay, that concludes the solutions for the second booklet here on relations and functions.